Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So let's see this problem. We are given an array of elements and our task is to find the index of second largest element in an array. To better understand this problem, let's see few examples. So if we are given an array like this, the elements of array are 1, 2, 3. Then the output of this input is 1. Because you can see that at second position 3 is the largest element, and at first position or first index you can see 2 is the second largest element. So the output of this is 1 because 1 is the index of the second largest element. Let's see next example. Here elements are 1, 1, 1. Okay, and here you can find that there are no second largest element present in this array. So that is why the output is -1, and here -1 represents invalid index. It means there are no second largest element present in this array. Let's see next example. Here we have 1, 1, 2. So 2 is the largest number and 1 is the second largest number. But here 1 appears 2 times. So it's okay to return the occurrence of first second largest element. That is why the output of this input is 0. In next example, we have numbers like 1, 2, 2, and here the second largest element is at the position 0 or index 0, and that is the number 1. Okay, clear. We have already seen a variation of this problem in previous video. In previous video, we saw that how to find the first largest element in an array, and this problem is just an extension of the previous problem. So if you have not watched that video, then I highly recommend to watch previous video first, come back here and continue watching this video. So now you have good understanding of this problem. So let's pause the video and think about an algorithm to solve this problem. So I hope you have watched the previous video, and by using previous video solution, you would have written at least basic program to solve this problem. So let's see the idea of a basic approach first. So why I am calling basic approach? Because in this problem, the basic approach and the efficient approach both are going to take same amount of time to solve this problem. The only difference is the basic approach is taking 2 traversal to solve this problem. On the other hand, the efficient approach is going to traverse only once to solve this problem. So let's say we have this array and the elements of these arrays are 1, 2, 3, 4, 5. So what we do in first step, we find the largest element in this array, meaning the index of the largest element. And we use the same code that we have used in the previous video. After finding the index of the largest number, we simply ignore this index and then we try to find the again largest number among the remaining numbers. Okay, so we got the largest number. Now we declare second variable with name second largest and we initialize this variable to -1. Why -1? Because we only know the largest numbers till now. We do not know anything about second largest number. Okay, why? The reason is simple. Sometimes you may get array like this. You can see this array that there is no second largest element present in this array. You can find only largest element. That is why we are initializing variable to -1. Means we do not know about anything till now. Okay, and then what we have to do, we traverse entire array in search of second largest element. So let's say we have initialized this variable to -1. It means we do not know about anything about second largest element till now. And then we pick one number at 0th index and that is equal to 1. Okay, and this time the value of SL is -1. It means we have never seen this number before. So what we do, we simply update the value of SL to 0. It means our second largest number is going to be this at 0th position, that is 1. So this step is done. Now we move to second element at the first index and it is 2. We check if 2 is greater than 1 or not. 1 is what? The number at the 0th index, and this time 2 is greater. So we simply update the value of SL to 1. It means the second largest element we got so far is at the index 1, and we do the same thing with the second number as well as third number. So we finally get our second largest number as 3. So at position 3 we get the second largest element, and we already know that at 4th position we already have the largest element. So this is the simple idea. But here we are traversing array 2 times. First when we are finding first largest element, and then second when we are finding second largest element. So this is the idea of basic approach. Let's see the implementation of this basic approach. So this is a function where we are taking, this function is taking array as input. First we are getting the length of array, and then we are simply finding the largest element, index of the largest element. And then we are initializing one variable with -1. Okay. So this variable second largest keep track of index of second largest element. Okay. Then we are running loop from 0 to less than n. Inside of for loop, in first if condition, we are just ignoring the largest element, right? And inside of this first, we again have if else. In first if, we are checking if our second largest is -1 or not. It means this step is corresponding to this first step, right? So what we are doing in this step, we are simply checking if we have never seen this element, then set this element as the second largest element. That's it. And if this is not the case, then in if statement we are checking if this element is greater than the second largest element or not. If this element is greater than second largest element, then we are simply setting second largest element as the I. It means the current index of the number we are checking for. Okay. And after the loop gets finished, we are simply returning the value of second largest variable. Okay. So let's quickly try run this code and see how it works. So let's say we have got an array of elements 1 to 3. The index are 1, 0, 0, 1, 2. Okay. Initially the value of L is 2 because we found the largest element at index 2, and the value of SL is -1. So it means till now we do not know anything about second largest element. So our loop begins, and in first iteration the value of I is 0 and the value at 0th index is 1. Okay. We check that this index is not equal to the largest index and this is not. So we get into this if condition, and then we check if second largest is equal to -1, and this time it is equal to -1. So we simply update the SL to 0, means we find the second largest element at index 0, and then we continue to next iteration. In next iteration I becomes 1, the value at index 1 is 2, and we check if 2 is greater than 1 or not. If 2 is greater than 1, we simply update the SL to 1, means now the second largest element exists at index 1. And in next iteration of I becomes 2, and 2 is not less than equal to 2. So this condition becomes false and we come out of this loop. And in the last, we return 2 as the index of second largest element. Okay. Let's see this example. Let's say we have array of 2 elements 1 and 1. Here our largest is equal to 0, means at the 0th index we find the largest element. We do not know anything about second largest. Our loop begins. In first iteration the value of I is 0, the element at 0th position is 1 and this 0, and in if condition we check if the value is same or not. Now it is same, that 1 is equal to 1. So we simply come out of this if condition and we move to second iteration. In next iteration I is become 1, and also 1 at first position we got 1 as element, and this 1 is exactly same as the element present at index 0. So that is why in this at this point also we come out of this. We never going to get into this if condition. So in this case also we are never going to get into this if condition. And in third iteration, as we do not have 3 elements, the condition of this loop becomes false and we come out of the loop. In the last, we simply return the value of the second largest, that was set to -1. It means we do not find the second largest element. So far so clear. So talking about the time complexity, as you can see that we are running loop 2 times. First, when we are calculating the index of the first largest element, and the second time when we are calculating the index of the second largest element. So it means we are running loop n times plus n times. So it becomes 2n, and we simply ignore the lower order term. So the time complexity of this function comes out to be theta of n, right? And what about space complexity? As we are not using any extra array or auxiliary space, we are simply using some variables to solve this problem. That is why the space complexity comes out to be theta of 1. It means this solution took theta of n time and theta of 1 space to solve this problem. Okay, great. Now you can see that we are traveling this array 2 times. One time when we are finding the largest element, and second time when we are finding the second largest element. Now the question is, can we do it better? Do we have any solution to solve this problem in a single traversal? Just observe the input array and think about a solution to solve this problem in single traversal. Okay, now let's talk about the idea for single traversal solution. So here we have observations to be made. First, we have to be sure that we are always going to get one number or one element in the array. We are never going to get an array that is having 0 element. So if the array has one element, it means we have the largest element. Okay, in that case our L is going to be 0 and SL is going to be -1, and SL is what? Second largest index. Okay, index of the second largest element. Because if array has only one element, it means we know about the largest element, but we do not know about the second largest element till now. Okay, now as soon as we get the new element, and it is a 3 in this case, and here the value of L is 0 and SL is -1. Now there are few possibilities that could happen. First is maybe possible that AI is greater than largest. So it means the new element we are getting is larger than the largest element. So what happens in this case? So previously the largest value is number 1. Now we found that the 3 is the largest element. So what happens in this case? Our new number becomes the largest and our previous largest become the second largest number. So here we are storing the index of the largest and the second largest element. Okay, 0 is the second largest and 1 is the largest. Okay, so far so clear. Now what happens if we get a number, new number that is exactly equal to the largest element? Okay, in this case we are getting 3, and this 3 is exactly equal to the largest element that is 3 only. So in this case we do not have to do anything, we just have to ignore this case. Now the next possible case is going to be, so first of all we have to be sure that now we have two numbers with us. First is largest and second is the second largest, because when we hit this condition we got our first largest and the second largest. Okay, that is why we have come to this point. So let's say we have elements 1 and 3 and we get new element that is 2. Now this 2 is smaller than the largest element. So what happens now? So this 2 is the smaller than the largest element, but this 2 is greater than second largest. So in this case what happens? We have to just simply update the second largest to this new element, because till here we knew that 1 is the second largest element, but now we encounter one new element that is less than largest but greater than the second largest. So it means this number is going to be our second largest element. Okay, moving on to next case. So what happens if we get a number that is 0? This number is smaller than largest number, but this number is also smaller than second largest number. So in this case we do not have to do anything, we just have to simply ignore this number, right? We cannot do anything about this number. Okay, moving on to next case. What happens if you get an array like this 1 1 and you get new element? So far till here you do not know about the second largest element, but you get new element that is smaller than the largest element, but you have not seen this element so far. It means your L is 0 and SL is -1. In this case if you see this element, you simply have to set SL is equal to 2, means you are seeing this element for the first time. So these are all the cases we have to handle when we see new element, and by using these observations and ideas we can find the second largest element in one traversal only. So let's see the implementation of this single traversal solution. So here we have a function that takes array as input. We are finding the length of this array in first line. In second line we are initializing the largest as 0. We are assuming that the first element is the largest element, and in third line we are initializing second largest to -1. It means so far we do not know about this second largest element. So and then we begin our loop from first till less than equal to n, and inside this loop we are in first if condition we are checking if AR is greater than ARR of largest or not. It means this condition is exactly corresponds to this condition. This condition means we found the number that is greater than largest element. Okay, so in this case we update the second largest and the largest. So our previous largest become the second largest and our new number becomes the largest. So far so clear. And in if condition we are checking if we get a number that is smaller than the largest number. In that case we have two conditions, and that is if we are seeing this number for the first time, and this condition corresponds to this condition here, and or if we are seeing this number that is greater than second largest. It means this condition corresponds to this condition, means the number we are getting is smaller than largest but greater than second largest, and we are not handling this condition because if we get number that is smaller than largest and the smaller than second largest, we just have to ignore those numbers. So that is why we are not handling this case here. So in this condition, we simply have to update second largest to the current element we are traversing. As simple as that. And in the last, we are simply returning the index of second largest element. So let's quickly dry run this code and see how it works. Let's say we have an array of elements 1, 3, 3, 2. Initially, the value of L is 0, means we are assuming that the first element is the largest element, and we are initializing the SL to -1. It means we do not know about anything about second largest element till now. Our loop begins, and in first iteration, the value of I is 1. The element at index 1 is 3. So we are here, and we check if 3 is greater than 1 or not. This time 3 is greater than 1. So in this case, so our previous largest become second largest, and the new number becomes the largest. Means 1 is our largest element now, and 0 is our second largest element. Moving on to next iteration. In next iteration, our I becomes 2, and the value present at index 2 is 3, and 3 is exactly equal to 3. So we are not handling this case. So this is the case we have discussed here, that if the value is same, then we just have to ignore here. This is the case we have encountered. Now in next iteration, our I becomes 3, and the value present at index 3 is 2. Now this time new element is smaller than the largest element, and largest element is at index 1, that is 3. So what happens in this case? We check if we second largest is -1 or not. Our second largest is not -1, means we already know about the second largest element. So we check if new element is greater than or equal to second largest or not. Now second largest element is at the position 0, means 2 is greater than 0, obviously. So we update the second largest to index 3. So now the value of largest is at the position 1, it means 3, and the second largest element exists at position 3, that is 2. So we get 3 as output of this input. It means the second largest element present at index 3, that is 2, and the first largest is 3. Okay, so far so clear. Now talking about the time complexity of this function, in this function we are not traversing 2 times. We are only running loop only 1 time. We are only running loop 1 time from 1 to less than or equal to n. So the time complexity of this code comes out to be theta of n, and the space complexity of this code comes out to be theta of 1, as we are not using any auxiliary space. So to solve this problem, we are taking theta n time and theta 1 space. I hope you got it. Now, before we end this video, let's have a quick recap of what we have learned so far. So we are given an array of elements, and our task is to find the index of the second largest element. So to solve this problem, we saw 2 solutions. In one solution, we have seen that we are traversing 2 times the same array to find the index of the second largest element, and the time complexity of that solution is theta of n. Then we saw the second solution. In that solution, we are only traversing the array once. In that solution also, the time complexity came out to be theta of n. The only difference between 2 solutions is, in first solution we are traversing 2 times, and in second solution we are traversing only once to solve this problem. So obviously the second solution is the best solution out of 2 solutions, and we can say that solution is the optimal solution to solve this problem. So this is it for this video. Thanks for watching, and see you in the next video.